Let's look at another example of a composite function here. All right, here we have given the functions f of x is equal to 3 divided by x squared minus 1 and g of x is equal to x plus 1. Find the following and state the domain. All right, this part is asking us to find f of g of x. F of g of x. That means we are plugging in the function g of x into the function f of x. Again, this is the first thing I write down. Go one step at a time. Next, we can begin to work from the inside out. What can we replace g of x with? Well, g of x is equal to x plus 1. So we can substitute that in. This means f of x plus 1. That means I'm going to go to my function f of x, and I'm going to replace every single x in f of x with the quantity x plus 1. Put it in parentheses. That gives me 3 divided by the quantity x plus 1 squared. Again, I'm replacing x with an x plus 1 minus 1. Okay, we can do out some algebra to simplify now. Expanding this x plus 1 quantity squared, that leaves us with x squared plus 2x plus 1 minus 1 gives us our final answer. F of g of x is equal to 3 divided by x squared plus 2x. Now let's see if we can't determine our domain. To find the domain, we must analyze the domain of the inside function and the composition as a whole. Let's look at our inside function first. Well, the inside function g of x is equal to x plus 1. Again, there are going to be no restrictions on domain. I don't have to worry about dividing by 0 or negatives inside of radicals. All right, now we can look at the domain of our composition as a whole. Well, here I have a denominator that could potentially be 0. Again, let's translate our rule. X squared plus 2x cannot equal 0. Factoring this, because it's a quadratic, we can factor out our greatest common factor of x. We end up with x times x, the quantity x plus 2 cannot equal 0, which tells me that x cannot equal 0 and x cannot equal negative 2. So my domain of my composite function is going to be the overlap of both of these. All right, well, that means my domain is going to be all real numbers except for negative 2 and 0. If we were to write our answer here in interval notation, we would have our domain is parentheses negative infinity comma negative 2 union negative 2 to 0 union 0 to infinity, all of those with parentheses. Notice we are not including 2 and we are not including 0. Let's look at this one. Same functions. Now let's find g of f of x. That means we are going to be plugging the function f of x into the function g of x. Well, working from the inside out, what can we replace f of x with? F of x is equal to 3 divided by x squared minus 1. G of 3 divided by x squared minus 1. That means I'm going to replace every single x value in the function g of x with this quantity 3 over x squared minus 1. All right, let's see if we can do some algebra here. Well, to combine this and make it look a little bit nicer, we are going to have to get a common denominator. Can I rewrite 1 with the denominator of x squared minus 1? Sure. This gives me 3 over x squared minus 1 plus x squared minus 1 over x squared minus 1. Notice any number divided by itself is equal to 1. Now that we have a common denominator, we can add our two fractions. We just need to combine like terms in the numerators. That gives me an x squared. 3 plus a negative 1 would give me plus 2. I have x squared plus 2 divided by x squared minus 1 is my composite function. So now let's determine the domain. Again, always start off by finding the domain of the inside function first. F of x is equal to 3 divided by x squared minus 1. In this case, we know the denominator cannot equal 0. X squared minus 1 cannot equal 0. Now, this is factorable. Another way to solve this, however, is just to add 1 to both sides of the inequality here. We have x squared cannot equal 1, and taking the square root of both sides tells us that x cannot equal plus or minus 1. All right, those are our first restrictions on domain. X cannot equal plus or minus 1. Then we need to analyze the domain of our composite function as a whole. Well, again, we have a denominator. And what do we know about the denominator? It cannot equal 0. In this case, this actually gives us the exact same result. X cannot equal plus or minus 1. Meaning our domain is going to be values of x from negative infinity to negative 1 in union with negative 1 to 1 in union with 1 to infinity.